Hello, welcome to another video. So I thought I'll give a update on my new operating system project, which is starting out to be an assembler project, I guess. So I've been building my own assembler. We have a look in there. I don't know, got a few thousand lines of code. Doing it in C, and currently it can do a few different things, but most importantly, I've got it so it can kind of assemble a file such like this. So it's got support for the times operator, got support for expressions with like brackets and whatnot, and also support for the dollar and dollar, which I've kind of stolen from fasm. Push the wrong button. So if I search for like dollar, so dollar is always equal to the current offset, and dollar is the base address of the current addressing space. So I've kind of made the dollar, whichever is the base. The dollar is just always 0 at the moment, but dollar does kind of go up as you kind of write a byte. It will go up by 1. Um, and it also kind of supports other variables. And so I guess what I could do is have a look at the tests for the assembler. So maybe go a bit more screen and do something like that. So this is kind of all the tests that we have. So we've even got a equals operator now, so you can kind of assign things in fasm, which I'm kind of loosely basing this off because I've got the most familiarity, I guess, with that particular dialect. But yeah, so the equals is kind of like the EQU operator directive. And I believe it will do the same kind of thing as this, where you can kind of reassign things and kind of build up lists. So that all kind of works. Cool. We also check errors for that. This was the same old test case, test every byte pretty much. We can do quoted characters. We can do bracketed expressions. We can do commaed. This isn't an expression at the moment, but I kind of want to make it an expression so you can have a list of expressions. Perhaps, I don't know. I'll see what other operators it kind of makes sense to have a comment on. But at the moment, just DB. At the moment, there's not much else in DB. There's times, which is kind of cool, and so you can do some kind of funky things like this. These I put in because I was getting some memory corruption errors, so with just kind of slightly more specific test cases, which I thought was kind of odd. But I've kind of revamped the entire memory model. And so hopefully that sort of thing won't happen no more, and I'll potentially change it some more. This is kind of just testing the parser a bit and kind of number parsing, same as last time. Yeah, and we have this times operator. Yeah, and we also have in the times operator, we also have a percent, which is existing also in this. Don't want that one, but this one. Basically, it's the number of the iteration that you have of a times or also a repeat, which is another directive that exists in fasm. So that's that. And everything kind of passes. So if we kind of make sure that it's on that and kind of run through all the tests, it all passes. I currently have the problem that I have a kind of largish diff, like 1,000 lines, and added in 500 deleted. So, and I mean, that's not even including these new tests and this new file here, which I think was, well, we can go to that one and see that's 500 lines in itself. So, what I might do is I'll talk about this memory model first, I think. Because if we kind of do this, a lot of this patch is to do with that realloc. By that realloc, I mean memory model that I'm kind of going to talk about. So everything's kind of including alloc and doing that. There's some other things like the token equals, and that can kind of fall out in its own commit probably. But yeah, that is that. And because of having that pull, I kind of pass in that config in a few more places. I do add a few helper functions to like kind of do some things. But yeah, there's a bit dumb. What I might do is kind of walk through the allocator. So I was using malloc, well, mostly calloc, which clears the memory as well, but I was using that mostly, and then freeing, which it's actually quite a slow thing. So what I've done is made a very basic kind of allocator, which will allocate a larger page of memory at a time as and when it needs it. And then it will kind of have its own kind of table of allocations and free lists. And I've just done a linked list type thing for both of these. And the layout of these is very important because I actually reuse the layout and size. I reuse these structures to kind of cast between each other. So when you allocate something, you can kind of just reuse the free list that there was. And when you free something, you can kind of just reuse the allocation that was. So a bit more efficient with the memory in that regard, but maybe not in others. I didn't really want to include the array, which I already have, because the array now depends on this. So I kind of wanted to make it nice and simple. So we have a page allocation and a free list. And we also have this pool, which is going to be the pool of memory that we kind of get stuff from, I guess. And it's going to have a list of pages, it's going to have a list of free lists, and it's going to have a list of allocations. And pretty much everything has a capacity. The page doesn't, because all we really need is that bottom pointer, because this was malloc, or gets malloc, and thus must be freed. We could get memory other ways, like the thing's lost me at the mmap, I think it is. So you can do this and not need miss. Yeah, so you basically have the option anonymous, and then it's basically memory mapping a file, which is just memory, and then you can kind of use that as a larger allocation than you might want to do for this. For this, and just, I don't know, I'm kind of happy with how it is. If I notice it becoming a bottleneck, I can kind of fix it, but it's a short-lived program. It assembles the program, then it quits. So that's all it really needs. I have fairly similar kind of signature to that of malloc and alloc, except I have an explicit pool. So in malloc, there will be like a structure similar to this, but it's just be kind of hidden away in libc. So this way we kind of give it to the user to actually say, I want this pool to be used. And you can have multiple pools if you want. So by default, we allocate 4K of 4 megs of 4 megs of memory at a time in a page, which I thought I was doing 4K, but 4 megs it is. So basically, we'll allocate that page, and then it will sub-allocate stuff out of that. I'd kind of pull in this because I think I was using that in a few places. Yeah, so I still have that code, which I might leave in for now, I guess. We have a way of printing out the page. So it basically says stats of how many pages it has, prints all the pages out, how many allocations it has, how many lists it has, and prints them out respectively, all on one line, so you can kind of see it in the log. Nice. When we free the pool, we kind of go through all of the pages. We clear them out just so if there's any like dangling links, dangling pointers, they'll be cleared so they won't point to memory no more, and we free it. So that's that. And so insert free list. That's basically when we've either allocated something and split up an existing free list and need to kind of reinsert something, or whether we have freed some memory and now need to allocate that insert that free list back in. And what this will do is kind of have an ordered set of lists, and because it's a linked list, insertion is actually quite cheap. You basically just change the pointer of the before and the pointer of where you are to kind of match up. And if it's a doubly linked list, you have to do the reverse as well, but you don't have to shuffle any memory around, which is quite nice. So by doing it sorted, we're basically sorting on the actual address of the free list, and the free list is actually pointed to just before the memory that we're going to give back to the user. So we basically allocate a structure of a free list or an allocation block, which is the same size, and then the memory will be like the next thing after. So we sort basically on the actual addresses, and then we kind of detect when we are inserting something that matches exactly the free list before, in which case it can be converted into just one big free list. And then we also check whether the same thing is happening afterwards, so that when we insert this free list or merge it with the other, if it now matches exactly the start boundary of the next one, we will then kind of merge it in. And we also do that check right at the end after that, because that's like a mid-return type thing. Gotta love them. But so that's if we like kind of found it in there, and that's if we're like, when do we break? So that's like could probably just break there. I don't know, because we're merging it. Yeah, it's an interesting case. Anyhow, ignore that. Allocate page. This is what actually calls the alloc to get the page, and if you want more than a page size, so more than the 4 megs, it will just get that for you. And this is a bug that I thought I fixed. That this should be size of and alloc free list, because we need to actually have space to have the initial free list. Yeah, that I did it down there. and also a size of page. So we also need to store that page information. So at the very start of each page is a structure saying about the page, basically where it is, which but it also says the next. No, what does a page store at the moment? Yeah, it does store next as well, so it's a linked list type thing. Perhaps you don't even need the data on it because the pointer itself is the data. So then you can just kind of have this as a pointer to the next page. I know I might change that, but I might not. Cool. So this will allocate the page and kind of insert it into the free list because you might have already allocated a bunch of stuff. Realloc, that is goes through and finds the allocation that you currently have. If you pass in a null, then it will just return whatever alloc will do. This also has a kind of thing is it also has a clear function, clear parameter. So you can choose whether you want to clear the memory or not. And yeah. So it goes through and finds the allocation that actually exists. If none is found, then it kind of aborts, doesn't know what to do. That's like a double use after. I don't know. It's one of the memory things. It's too early in the morning for me to think. So this. We first check whether basically it already has capacity. So, like if we're asking for less than we already have, we can kind of just chop it off and add the leftover to a free list if there's space. And if there's not space, we just won't chop it off, but we won't tell the user that. And if there was not space, then we kind of need to make a new allocation. So what this will do, it will go through and find a free list that has enough space. Oh no, this is finding a free list that is right at the end of the space that we have, in which case we can just grow it. And if we are clearing, then we clear the memory that we're about to kind of grow on, then we do that grow and we break here. And if we didn't find such a free list that is right next to it, this potentially should break if the free list is this could do some early breaking. At the moment it goes through every free list, but because it's sorted, you can stop after a certain point if it's gone too far. But yeah, if it didn't find anything, then what it will do, it will allocate a new space with the new capacity. It will copy the existing stuff into that, and then it will free the stuff that you wanted, you already had, and then it will return you the new pointer. Allocate it's a go-to in it. So allocate kind of keeps track of the free list before free list that you're on, goes through, updating them as it goes. And if there's a free list that exactly matches the size that you want, we'll just convert it into an allocation, easy peasy. Otherwise, we will split up that free list and kind of insert that new split back into the free list pool after removing the old free list. This kind of removes the old free list by checking whether we have a pointer before us. Otherwise, we update just the pool itself. If we didn't get a pointer, that basically meant that no free list had space for us. We will allocate a new page and then we'll go to start. So I did go to start rather than recursively call this because I had these debugging things and I didn't really want to spam out lots of things when we're allocating pools, but it is what it is. And then if we wanted to clear it, we clear it. Which is interesting because I do this clear here. No, that's because I'm extending. Yeah. EZ. And then free, it will just go through and find the allocation that matches. And if it matches, then cool, it will remove that from the allocation pool, put it back into the free list pool, just swap it over. This should be lock insert free list and on the pool rather than doing that stuff. So if we kind of pull in whatever that was doing, you can see here freelist.next equal pools.freelist. Yeah, so that's just adding it to the start, but we kind of want to insert it into the right point. And yeah, that's just inserting. Cool. So fixing bugs as we go through. And that's pretty much it. And we've got a small main to kind of show what it is. So what I might do is add this allocator, get commit as new allo.page. Cool. And then what I reckon I might do is kind of just go through and find anything with a pool in it. And this is all pool related. That is all pool related. Yep. Yep. No, 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 no. What are we doing here? So I think I'll leave this because this is I did some other things of adding extra types, but I will do that. That will do. This has an extra bit up here. It has quite a bit of extra bit. So I'm of the opinion of just, I don't know, manning everything. It's just what I'm doing. So yeah, just everything on every file things. Well, maybe not that one. And update all the tests. Oh, we had some tests that were failing that I took out that I forgot about. What is broken here? We need that. I need to restart them and do that, restart that. And what was the other one that was in times? Running tests and not realizing that they weren't actually getting exercised. So there's a little GTI view. Cool. So if we have a look at what we have, we can even do no, we have to not do that. So a little bug fix. And a bunch of changing. I'll walk through kind of what I did for the equals and these things as well, because I added it all. I decided I didn't really want to split it up. So what I've done is I've got this thing called a scope, which looks like I did have a scope in a previous commit, but yeah, basically the scope is all it really is a map of a string variable to an expression of something, and not a computed expression, just an expression. Gets computed at the time that you compute the variable. That makes sense. And so the scope will also kind of have a notion of a parent. Before it was like a array of things, which I found this to be a bit simpler. So that's that. We also have an identifier, so pretty much any string that is not parsed is now treated as an identifier. Might make it a bit smarter and make it so if it starts with a letter and then followed by numbers, then it is. Key thing to note is a dollar and a double dollar and a percent is treated as an identifier, I believe, in the tokens. Which, when I did, I wondered, I wonder how you do a modulus. And I actually looked it up, and in fasm, you actually don't have the mod like C has it. You actually have a keyword mod, which I'll probably have to end up doing when I add in those things because of the choice that I've made that percent is that. Otherwise, like I'd have to track it as a token of percent, and then at the time of checking, like consuming the token, I'd have to work out whether I'm in an expression that it can be treated as a bin up, or whether I'm not in an expression and it should be treated as a unary. Well, not a unary, just a value in itself. Back to the diff. So I also made a way of duplicating an expression. I think in the last video, in fact, I didn't really walk through at all this main file, did I? It's got 2,000 lines, but just I've got a bunch of X macro type things that define all different types of things. And I've got a token, expression, a computed expression, and a statement. Statement can have certain things, so you can then have a binary operator, which I think should really be yanked up to the expression point because that's where it is, and also a unary operator. And then does things with the X macros to define them all. Then a token, pretty much everything has a span, so we know what it is. Everything has a type relevant to the thing that it is, and everything has an int pointer. And an int pointer is something that can be converted to and from a void star. Basically, any pointer can come to and from. But it can also be treated just as a literal integer, which is what is done sometimes. But yeah, so pretty much everything of those types that I mentioned had that. The binary operator is a bit different. It has a span and it's got a left-right. So basically a left-hand side and a right-hand side. A unary has just an expression, but it's also got a span. Even the DB has a span, and it's got an array of expressions for the values. So that's the comma operator, which I could potentially make it just one expression. Hard to know. Times has a span, but it also has an expression, the number of times that you want to repeat something, and so that is computed at the time that you do that time statement. And then the statement. Then we have a scope, as I was kind of mentioning before. Then we have a kind of config thing that we kind of list all the things that we have. So we have a string view of our entire source. So all of the tokens are kind of string views of within that kind of source kind of boundary. It's all allocated once and then reused multiple times. We also have the source path, and we also have where we're outputting it, and we have a string builder to output it. Easy peasy. Right, and so we have a way to free a bunch of things. And depending on what they are, we have to do other things. All of these frees, I believe, kind of do a mem set as well, which is kind of nice. We can duplicate an expression, deep duplication, I believe. Back to freeing things. That dupe was in a strange place. More freeing things, it's, I don't know, you just look through all the things that you have. And because I use compile with asm, it tells me when I have memory leaks at the end. And then I'm like, cool, I just need to add it to that free statement or free whatever. Or I need to work out where I need to call the thing or whatever. So that's all that. I've got a helper to print a file location of, like, you pass it a token, so you're just passing it a span of where it is in the file, and so that's kind of a byte offset into the file. And we use basically another view of the entire file, chop off all the new lines and work out which line it's on, which character of the line, then print out a kind of that nice-ish formatted thing that my editor will just jump to the place that it needs to jump to. Just more help with things for printing things. Print pretty much all the things that we have, just so it's more debugging, that kind of thing. Here's where we're kind of converting to and from things. So if we already have a computed expression, and this is used in the times case, or it's used in some situation where you have computed something, then you want to kind of say, oh no, it's just used in the equals case. So you have an expression, you want to compute it to know what it is, and then you want to save just an expression of the computed value. So it basically gets it into just a kind of literal, I believe. Yeah, so it's either a literal string or a literal number, or number pointer if it happens to be outside the range of the long stuff. I don't know if that will ever happen, but I put it in. I'm sometimes very cautious. Then we also have a way to make a computed expression from an expression, and that's basically if you have a literal number or a string, then you can kind of upgrade that into a computed expression of the same type. And if you had a different thing, and then that's an error. So you should check whether you had a different type of expression before you call this function to make a different thing. Man. We have some like helpers to like kind of you pass in just the each value that you want, and it will kind of bundle it up into a declaration like this, and then kind of call the actual function with the actual type, just put on the stack, essentially. But yeah, so this will allocate the thing of the type, and I feel like I can do some macros to kind of reduce these down because they all essentially do the same thing. just the type is different. So that type, that type, that type, it still just does a cool equals that and that type, of course. Everything else is very much the same. So I wonder if I can kind of make some things that do that. Here we basically check whether a number is within the range that fits in this value that supposedly fits everything, but might not fit everything. So if it doesn't fit everything, we just have it as a pointer to the literal number, which is just an extra layer of indirection, and we have an extra different type to kind of allocate that. That weirdly is in between all these make things, which again are the same as the others. We have a way of parsing escaped character. So basically, if you have a backslash, then some other character, it will kind of convert it into what it needs to be. We pass a token, have some macros to kind of help out with that. Basically, here are all the strings that kind of get converted into these tokens here. And then we try and convert a number, or then we I did call them dollar and double dollar. I lie and take it back. But yeah, percent we use as identifier. I suppose because dollar and double dollar, you do kind of need to know what it is, I guess. And then we try and check for just a character, and then we try and check for a string. And if at any point one of these matches, we return the type of what it is. And so if we match a string, we do a bit more, and we kind of build up each of the escape characters. So you can do escape characters within the string, literal. And then we basically check into one of these special characters, which is basically these are all the things that would match is space, and the things before it. These three characters are basically used as perhaps they're like the only. There are a couple others. So I wonder if we need like these three single characters as well. Yeah, it's kind of interesting. Might have found a bug, but this again, I should probably change into if it starts with this, just go until it's not one of these characters, which is how most languages do it. Like, I can't have a variable called this, like, it just doesn't know how to parse it because it'll see this and think it's a number. In fact, my parser will also kind of do that. But I am allowed numbers after the fact. It won't parse that as a number, it will parse that as an identifier. But I also can't have something like this as a variable because it'll be like that is starting a character in C, and so you can't do smaller. So yeah, this bit probably needs changing. Perhaps I'll do like a little fix me, maybe a more modern fix me. This should be more normal and check alpha plus alpha num star, something like that. Currently this would match like stuff like that. It wouldn't actually match that one. But yeah, I don't know. Just an example. But yeah, so that's basically making everything into a token. If we got to end, then we basically have an end of file. We build up all the tokens into an array so we can kind of refer to that as we need. Then we have kind of a way to peek and look at the next token as we're consuming the tokens. And that way we can kind of roll back if we kind of hit an error. We have a way to consume and way to roll back and get the current index, I guess. And that was mainly to kind of have the logging in there, bringing those functions out. Got some more make stuff that should probably be worked up to the top, but yeah, we're just making literal expressions. And here we can parse an expression. So this is what it will do is work out where we are to start with and kind of trim all the white space. And then depending on what thing it finds after that white space, it will do a thing. So if it finds an identifier, then it will make an expression of that type. So on and so forth. Some things might need a bit extra. So if it's a number thing, then it needs to be a different thing. If you get a minus, then it's actually a unary operator. So you need to parse the next expression after this point and kind of bundle it up. And if you get a left parenthesis, then it's kind of a grouped thing. So kind of parse the next thing and make sure that we have make sure that we have that right parenthesis at the end. It's quite verbose kind of saying that. I could kind of condense that out by making some helpers potentially. Otherwise, we do some things. And so then that's doing a weird thing. Can also have just a character or a string. And then after we get that expression, we then check if we have like a plus or a minus, and they will kind of grow as more things happen, like a mod or divide times and whatnot. And that builds out binary operators. And then at the end, it kind of shows some state of what's happening. When we're computing stuff, we compute binary operators by computing the left-hand side, then the right-hand side, then doing whatever operation it is to kind of combine them, and then making just a literal computed expression out of that number. If we have a unary expression, then we basically do the same process with whatever operation, which currently is only a minus. If we have an identifier, we get out of the scope, which will kind of get it will return a pointer to the scope that matches, basically. So it will check our scope. Is that key matching? Yeah, yes, cool, return us. Otherwise, it will recurse into the parent. And if the parent is null, it will have a base case of returning null. So that way we can kind of get the value that we want and then kind of compute that expression. And then that's computing the thing. If we have a dollar and double dollar, it just gets the numbers here. So either the current output size or 0 for double dollar. And so the percent is not done there. The percent is actually done within the times operation, which is probably coming up. And so some more stuff. So if we are parsing a db expression, this is going to parse an expression, and then it will basically try and find all the things with a comma after the expression and kind of bundle it up into an array. And when we're parsing a times, we'll get the times keyword, then we'll get an expression. then we'll kind of expect some kind of white space between the times and the expression and the statement. I think like you just need to prove, yeah. But I don't know. Other parsers don't really kind of care about white space. You can't get by without, but I've just done it this way. And then you pass the statement afterwards, which could in fact be another time statement or whatever. And it will just keep kind of recursing down. And at the end of it, it will have a span that matches whichever kind of grouping it kind of matches. And you can dive into each one, and that has a span of each smaller subcomponent. So if we're parsing just a general statement, this is where most of the magic happens. We first check whether it's a DB, then we'll call that helper, or it's times, and do that. Then if it's an identifier, we probably should call a helper, but this basically just makes sure that after an identifier there is an equals, because it doesn't really make sense if there's not. And if there is an equals, then we'll pass an expression, and then we'll allocate that expression as like a copy of the expression, because the expression could get white, I believe, is like there's some reason why I did that, I think. And then that will go into an assignment operator. Easy peasy, and then does things. So if we're executing a statement, if we're doing a DB, it will go through all of the values it has, compute them all, and then just write out whatever that character is, which I realize this might not output a null byte, though it seemed to. Yeah, it seemed to work, I think. Yeah, because I'm always DB zeroing and it is outputting that. That's cool. So if we get times, it gets a little bit more funky, because what we do is we compute the expression that we have. If we get a string out of it, that's kind of a bit weird. Otherwise, we get the number, and then we loop over the number, and then we kind of make a new expression of the loop plus one, because it's one index for the variable percent, and then we kind of make a new scope that is just being used for this statement. Then we execute that statement with that, and then we free the scope straight away. I tried to do that on the stack, but there was some issue there. But that's that. And if we have an assignment, then we basically do similarly. We compute it, and then we allocate the scope for the expression, then we chuck it on. And the main basically just reads the file, tokenizes it, and then goes through while it has a statement, executes the statement, and then done. And it is capable of booting and doing nothing else, because the first expression is hello, which is not actually a valid expression. So it will be like doing something weird, but it does have these magic bytes, and it does kind of start with a bunch of zeros up to the right point, and then hello kind of proves that it will kind of work out the right number. But I think that is probably good to go. I might also add up that, and also add up, yeah, sure, and commit from video, because that's what it is. But yeah, I hope that kind of gives a bit more insight into what I've been up to, and I'll see you all next time. Hopefully you enjoy this, and hopefully next time I might be able to do a bit more live coding. Like it's getting to the point where it's I can start. Cool. I want to do this. I want to do this. But yeah, for now I'm kind of just going slowly, one by one. Not always committing when I should, but yeah. For now, thanks, and I'll see you next time.